a little diagram of what we want the thing to actually do. We're probably going to create a little scaled down version of this, just a test. But the idea here is that you have the buttons interlaced in this kind of matrix where you have some kind of inputs and some kind of outputs. So these ones here will all be outputting, and depending on like the status of each of these pins, we'll be able to turn how each of them turn on. Maybe Alan, you can help me understand how that works.
Yeah, so what is that? Our goal for the Stream Deck, now that we have a proof of principle that we can actually make an actual Stream Deck, the proof of concept only had 3 buttons, but of course we want more. And we looked at other companies' Stream Decks, and they had, the Elgato one, for example, had 15. So I guess Jordan, he wanted to have, well, at least one more.
We have to go one more because
one more.
That's just going to make us just better than
just one more better. That's all you need. One more. So you want to have 16 buttons. Well, if we did things conventional way, that one single input per button, we need 16 inputs on Arduino. I don't think we have that. I don't believe. I think we've run out of pins. I think
we might actually have enough.
Oh, because we want some pins for the outputs as well, for the LEDs.
Yes, that's right. So actually, with the outputs of the LEDs, we actually don't have enough. So now we have to figure out some way that we can have enough pins to do our buttons, but also enough pins to do our LEDs. Especially if we want a bunch of buttons that light up, right?
Yeah.
So we want to have a plenty enough for both. And the way that we can do the LEDs and the buttons is in a configuration like so. So imagine this kind of this diagram that we have here where it's all the buttons, but instead of push buttons at these locations, we have LEDs.
So in this case, it would be like X and Y, so to speak, and we want to turn on a particular LED at a particular place. All we'll do is just make the one line is ground and one line is, for example, +5, and that particular thing on that place goes on. So this is the way to selectively turn on LEDs. But in this case, we can also selectively use it to scan push buttons as well too. This is a matrix scanning, and this is actually the same technique that, for example, actual keyboards do use as well too. You have a circuit that puts a voltage on a particular line, it selects a particular key, and it checks whether that key is actually being pressed or not.
So is that how we're going to do on the outputs? Is that we're kind of like scan through them by activating them?
Yeah, so for example, let's assume that these are our outputs. These are connected as output pins on the Arduino. For example, we can turn this to high and all these to low. So therefore, the only thing that's being scanned is the only things on this row. So if someone contacts, for example, this one here, therefore this high goes to this button, comes through this input, and we register, this input is being hit on this row. And so we can actually selectively disable that, turn this one, and we can check if anything else is pressed here, and so on. So this selects a row to check, and inputs tells us which of those buttons on the particular row has been depressed or not.
So are we going to be like scanning them? So will it go it'll go high, low, low, low.
Yeah.
Then the next one will be low, high, low, low.
Yeah.
And the next one will be low, low, high, low.
Yeah.
And then low, 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 high.
Yeah, we can do that. Another way we could also implement is that, for example, use some kind of shift register or some kind of counter as well too. Saves us in terms of pins, but that means more components we have to add to our board. So it's a compromise. Sometimes it's easier to do it all in software. Sometimes it's easier to add more hardware. In this case, we're just doing it purely software first to see how far that gets us. Because a lot of people don't want to buy more chips to solder. They want to just buy maybe one single Arduino. So we're going to see if we can make that possible.
Yeah, we would really love to eventually have a kit for this. If you guys are interested in trying to help fund the kit, you guys can check out my Patreon. It's not 100% set up yet, but I'm going to be starting a Patreon specifically for making these little electronic kits to help you guys get your own version of the projects that you guys are seeing us build. So, but yeah, we came back after a little bit. Take a little break.
Yeah, we decided we wanted to do a little bit more.
we always get to the point where we're like, gotta hack at it a little more,
Yeah, we did
get hungry
beforehand, so therefore we had figured it out. Therefore, we want to stream what we made in terms of decisions in progress.
There we go. So what am I doing right now? Here, let me bring this over so y'all can see what I'm doing. So I've got some chips here, not chips, but buttons, and we're going to basically add the rows together. So this is all lined up. This is going to be lined up. This is going to be lined up. This is going to be lined up. But the other side of the legs, you can see that each push button has like a left side and a right side. You can see that from the front here. So this left side will be all like the horizontal columns connected, and the right side of these pins is going to be horizontally collected.
Horizontal rows.
So I'm just going to shove them all together.
So this is all proof of concept, just to make sure we understand that we just want to make sure we do start small and make sure it works properly before committing too much work to building the full 16 push button setup. But all we have to do is just prove that this works with this, and then we know it works, and therefore we later on when we build it in large, we're going to trust that it will work. We kind of did all the debugging at this stage.
Oh, I see. One of the buttons is off. That's why I'm like, this is bugging me. This is off. One of the buttons needs to be moved over a row, just like that. Now plug that in there. Oops. And also, we finally got we have the stream name correct this time. So it's not going to be gaming Valentine's with my muser. It's going to be actually the stream.
Thursday night builds.
That's right. Okay, so there we go. So we've got the left side all hooked up together.
Okay.
Now I'm going to try and hook them all horizontally.
Wise.
And I'm actually going to need a bigger jumper than the ones I've got here. So time to strip some jumpers.
Yep. Yeah, wire now.
Got some wire here. That'll probably be good enough.
Yeah, it's really nice and having nice circuit cam.
This is great. This is awesome. I got excited by the circuit cam, and I was like, I want to stream a little more.
Oh, that's another thing we did. Is that you know you can actually have a separate camera, but hey, do you know that you already have a really good camera, webcam already that you don't have to pay money for? How?
Huh, it's almost like we bought a really nice camera.
Like if you look at the definition and color and all this stuff, hey, it's really good looking.
Yeah.
So what brand is it? What brand is this?
It's a Samsung webcam.
I never knew that Samsung can make webcams. How much did it cost you?
A few $100s.
Whoa, that's a pretty good webcam. Does it come with any extra features?
Oh yeah, you can use it to make calls. But, you know, that's secondary.
Yeah. So it turns out there's an app called DroidCam. It's made by Dev42 Apps, which is actually located in our hometown of Vancouver, actually.
What, really?
Yeah.
I had no idea.
They're a local company. But anyways, it's an app that you download onto your Android phone, and you go to the website and download a corresponding app for your computer, either Windows, iOS, or Linux even. They actually support Linux. And what it does, it allows your camera to stream its video to your computer. And essentially it acts as more or less like a de facto webcam, a wireless webcam. So it gives you the ability to actually have more than one webcam. It actually provides you a better image than typical webcam even. So
I would say so.
You can use it in lieu of an actual webcam. It has way better low light performance. So right now, you actually don't know how dim it actually is right now, the environment. We're actually in a living room right now. It looks relatively bright and on
nice,
screen, but it's actually
quite
much
dim.
dimmer in real life than what you see on the stream right now.
Yeah, I bet we could actually you can drag that.
Yeah, well,
that film over.
More light in here.
Thank you, Alan. Because I bet that we could probably improve the image quality by giving it a little bit light. Okay. Okay. Okay, so now what we got here? Well, we've got our rows of buttons, and look at that. That's actually pretty decent. We were originally just going to do a 2x2, but now we've got a 4x2, and that's actually still pretty decent. Like, that's pretty reasonable, right? Because you only have 2 horizontal lines and then 4 vertical lines. So that's going to be 1, 2, 3, 4, 5, 6 outputs, right?
So 6 lines, control 8 for now, but it's not that efficient. But again, it's proof of principle. We're going to get better results when we go for a full 16 by 16, which only requires 8 lines altogether.
Okay, so now we're going to plug this bad boy together. We've got some jumpers, and we have our new Hackduino here, which is going to be a little more painful to program, but whatever, we'll see. So I'm going to grab some brown ones here for the lower lines, and I'm going to grab some gray for the other lines because it's closer enough to the white lines. So just at the end of each of these lines, I just want to connect these up with a little jumper. Gotta grab them. And then at the bottom of these poles here, get a little jumper here. Boom, boom, boom. And again, we're pretty much following the exact same diagram that's underneath. So imagine that it's like this, but it's only like
that big or so. Yeah,
it's only
D6 and D7 are input. Actually, maybe D4, D5, and then we have D0, 1, 2, 3 is probably the input, I guess. And D1, D1 and D4 will be the output, I guess.
But there we go. Now we've got our little thing here. Now we can test it out.
Yeah. We'll clear a new screen environment. Let's put our stuff down the corner, this hardware down this corner, and then the main screen will be the Arduino because we're doing some coding now.
Okay.
Yeah.
So do you want to just add that here?
Yeah.
Okay. Add. Window capture. Arduino.
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 No. Arduino. Okay. So we're gonna do Arduino.
Yeah.
Okay. Add this in Arduino. Put that underneath.
I don't think we have Arduino open. Yeah, we should open it up.
Yes. We just basically lost our minds for 30 seconds there. That was funny. Okay, so this one should be underneath everything?
Yeah, so it'll be underneath everything. And we actually want the hardware maybe in the corner because we're going to be pushing buttons to test it out as well.
That seems to be good.
Yeah.
That.
And
we want to make this one a little bit smaller, maybe?
I should make that fill the middle of the screen. And then we have the hardware in the corner because we're getting...
Yeah?
Most of the stuff we're going to be doing in a few months is going to be coding.
Should I make a new one then?
Yeah, I think actually we do. So
let's just duplicate it. We'll make this one hardware hacking with Arduino. So we'll just make the droid cam a little smaller, like that, and then I can make this one even a little bigger, like that, because that's pretty much how much big we had it last time.
Yeah.
And this seems to be pretty good actually.
Yeah.
Should be able to.
Can we show ourselves a little bit more that way people can see a little bit more of the coding, perhaps.
The camera.
Yeah. That one. Maybe bring it down, or maybe I should put it in the corner. What do you think?
Maybe I can just put it up here. We don't really need the top right corner.
No.
For webcam.
Yeah. But we want people to see the whole code. We want to see what we're doing hardware-wise. So maybe like 50-50, or what do you think?
This is probably good, right? Is that okay?
Well, I noticed it's getting a little cut off on the edge. So.
Oh, for the Arduino?
Yeah, Arduino.
Do you want me to pull it up or something?
No, I just want to make it a little bit wider. Can you widen this side maybe, or because we like people to see the whole line of code properly. So we want.
I think so. I think we got it.
What do you think? Looks good now.
I think that's good.
All right.
Okay, cool. Now we can make a new thing here. We're going to be calling this.
Okay, this is
button array.
Matrix keyboard.
Yes, Matrix keyboard.
Keep it same deck. All right, there we go.
Okay, so now we got to program this thing, and I realized that without a programmer, programming this Arduino is going to be a pain.
Okay, maybe we should just sacrifice the existing project, or not?
Maybe we should, because it's going to become the same thing, right?
Yeah.
But let me see if there's another Arduino in here that's a little more easy to use right now. Nope. Okay, we're sacrificing that little project. Well, if it takes more than 30 seconds of looking, it's not worth it.
Yeah. And we don't want to mess around with the programmer at this point. We just want to get things to work.
Okay. Well, wiring this thing up was super easy anyways.
We kind of know the principles. We can get easily duplicate it. So just move this aside.
Yeah, you want to just put that
Put it
over there?
So put it over here for now.
And I think we're just going to use the same pins as we were using before.
Actually, we should probably label on the diagram itself. What do you think?
Oh, yeah, we should.
We should. So, we actually can't use D0 because D0 and D1 are reserved for the
Input, output.
Well, it's reserved for the serial RTS and DTS.
Is there garbage over there? Can you throw those pieces in there?
Yeah. Put it here.
Should I change? I can't write on it upside down, so let me flip it around.
Yeah, so we'll flip around. Because normally, actually, you don't want to commit yourself to using pin 1 and 0 because they're for the transmit and receive on the on the USB.
Well, that's what we called it here.
Yeah.
I guess we'll have them go to actual.
We can give them name one. So I guess D2 is safe and onwards. So we guess go. This is D2, 3, 4, 5.
So should I change? Just erase them?
Those. Yeah, let's erase those. So we're going to actually use the actual ones just to make it easier. You don't do mental translation.
Yeah.
So the other thing you don't want to do when you do hardware projects is do mental translation stuff. You just want it literally what it is.
So D2. Oops.
Yeah.
Oh my god, that made me cringe. D2, D3, D4, D5.
And that'll be D6 and D7.
There you go.
There you go. So, and I guess we're going to configure these as, I guess these ones are going to be inputs, outputs. I believe they're going to be outputs. Right, so these are outputs. So we'll flip it over.
So just out. So just O?
Yeah, so just hit outputs. So
just out?
So bracket, these are all outputs. So we know that these are going to be considered outputs on the... So all these are outputs. So we're going to do scanning across this way, and this is the inputs.
We should label this matrix keyboard.
Yeah. Here we go. So that's essentially our schematic of what we're doing, and we're just gonna stick it in the actual pins.
Okay. Right. Let's do it. Nothing left but to do it. Let's get to it. Okay, and now let me plug it in. Oh, this is the exciting part.
Actually, no, yeah, it should be fine. So even though we configure the pins a certain way, shouldn't we should
unplug it?
No, we should temporarily unplug. We should configure the software because we don't want to fry something by accident because the pins were still kind of putting out signals in the last configuration.
Yeah, so we'll just
so essentially we'll just reset all the pin modes and stuff.
So we just run a blank sketch. Put a blank sketch on it.
Yep, I guess.
Where's a blank sketch?
Well, actually, we can easily do it. We can do from memory now.
Yeah, but maybe if I can use an example here.
All right, so letting people know that the Arduino environment is quite nice.
Yes, so there you go.
Yeah. Oh, but it isn't showing up. It only shows the last thing. It doesn't show up the.
Oh, it doesn't show all of it.
Yeah.
Oh, well, that's okay. We're just gonna upload. We're uploading a blank sketch in a different screen. Let you guys know that.
Just copy that and paste it.
Oh right. Yeah. Okay.
Select all. Yeah, there we go.
Let's upload this now. Make sure that we're going to the right com.
Yep.
Okay, we're uploading right now.
Yep. And let's resize the screen because I guess it got resized a moment ago. That when we're supposed to do stuff, let people see what we're doing.
Oh, what the heck? It just keeps getting shrunk. Maybe I'll just go like that. That's good.
Yeah.
Cool. So now we've got our thing here. Let's double check. It looks like it's running. It looks like Sketch now.
All right. Okay, now we
Now I can plug it in?
Now we actually plug things in. Top, maybe.
I think this is, these guys should be routed down to the bottom. Like down here or something. Yeah, I'm going to do that. Wait a second. Do you have the... Oh, where? Oh,
Right there.
Right here. So I'm just going to jumper those guys over so that it makes a little more sense. I don't have to reach over and stretch. Makes everything a little more sane. There you go. The only thing I'm doing is taking that line and running it over to this line here. Okay. Oh, that was not long enough. Crap. Yeah. One in there, another one over here. Boom.
Okay.
So now we've got it all running in, and none of the wires are being pulled. The reason why I did that is because these wires were getting pulled, being all the way over there. So now this is a little nicer, and now I can actually access the buttons and press them.
So now the second thing is we're going to configure these pins according to our diagram. So we want to configure as outputs D2 to
You throw this
D5.
in the thing.
So looking at our diagram, D2 to D2, D3, D4, D5 need to be configured as outputs. So therefore we have to go
I wish
to
I had another table for the keyboard now.
Yeah.
Can I have another table somehow?
Yeah, let's actually pull that one out.
That one I have to like kind of crouch over, but that's okay, I guess.
Or you can maybe put it in your lap. Would that work?
Oh yeah, I could put the keyboard on my lap. That's a good idea. Okay, so we're gonna do pin mode.
So we want, looking at our diagram.
Let's just move this for a moment so we can look at our own diagram.
Yeah, so upwards like here. Okay, yeah.
Okay, so D2.
D2.
So that would be just 2.
Mm-hmm.
And now output.
Yep.
Pin mode 3. Output.
So we can just copy paste and just change numbers.
Pin mode
4. Output.
output.
Oh yeah, I misspelled pin mode.
And then pin mode 5.
5.
Output.
And then on this edge, we want
Pin mode 6. Oh my gosh. Pin mode 6. Input.
Input.
Pin mode 7. Input. So now we've got all of those set up.
Yep. And we want, I guess we want to create a function that I guess reads these now.
Yeah.
So,
So I guess we'll call it read keyboard.
button.
Read button.
Or read keyboard. I guess we call it matrix read keyboard. All right, so we have that. We also want to have, I think we actually need an array of which buttons actually are actually depressed as well too. What do you think?
Sure.
Yeah, because we want to actually record, which of the 8 buttons are being pressed.
Yeah.
I'm trying to think, do we need an array for that? I would think that have an array of 8, so element 0, call it buttons 0, 1, 2. We can check which one's on. So our function read, I think, would just scan those, set those things.
Oh yeah. That's a good idea.
Yeah.
We should have an array of Boolean.
Yeah, because status or buttons or something like that we toggle or whatever. Eventually, right? Eventually, we're going to create some kind of class of some kind, just like the way we did with debound.
Should we just reuse that?
We can't, because that works on individual button basis. Because this is matrix scanning. So first is when we just get it to work first, and then we're going to make it nice. Just the same approach we did the last one. Because we wrote the raw code last time. Okay, how to make it nice, and that's how it came up with the nice debound. We want to make it work first.
That's a good idea.
Yeah. Okay.
So now we're reading keyboard.
Yep.
So now what we're going to do is we're going to I put power in each of the outputs.
So we need actually a
array,
for
right?
loop, right? Yeah. We need an array. So we need to initialize a data structure to record. So call it buttons.
Output array. Button output.
Or call it buttons.
Button out array.
Button status.
Button status.
Yeah. Or not button status, but button status. What do you think?
Buttons status.
Yeah. Or status is. Status is an awful word.
Button matrix.
Button matrix. Okay, I'll call it button matrix.
Okay, so we got.
Okay, but
buttons is.
Buttons.
Buttons is.
Maybe just call buttons. What do you think?
Buttons.
Buttons. Maybe buttons. Just buttons. Verb.
I like that. Buttons.
Buttons. Okay, but you remember how to call it to type. So this should be, what do you think, Boolean?
It should.
Yeah. So we have to say Boolean, because remember, types, and then buttons square bracket. That's how you create an array, not equal square bracket. Semicolon. Then I think we have to set the type.
Like that?
Yeah, I'm trying to recall if we initialize it. So essentially we have 8 of them, so it's just be all off, I guess, right? So it'll be 8 falses in a row because we're initializing it.
Yeah, here, let's move the mic here so we can hear us a little bit.
All right, so
let's move that DVD and just put it off to the side because.
Okay, you need to sell that, right? So
yeah.
Here.
Yeah, right there.
Put it right here, just so you remember too that this is.
Just maybe put it inside of the basket there, and then it won't fall down.
There we go.
Perfect.
That we know it's. Okay, yeah, we need to initialize it. Because it's going to be 8 elements. Well, 4 elements for now. No, it's 8. Yeah, we have 8 matrix. So it'll be just false, 8 of them.
So we just say that?
Yeah.
Buttons equals to, it would be false, comma, false.
Yeah. I think it needs to be lowercase for false. Because it's not showing. Yeah, there it is. False, comma, false, comma, false. Because with C and C++, you need to.
How many falses do we need?
8 of them altogether.
1, 2, 3, 4, 5, 6, 7, 8. And the semicolon?
Semicolon. Okay, so that should initialize all the buttons, all to false. And
now we need to read through them and find out.
Yeah.
So read keyboard. Let's try and figure out the first button. So the first button is going to be. How do we read through them?
Well, we have to select, for example, a row. That means the output, right?
Yep.
So these outputs we have to consecutively go through total 4 outputs, right? So I guess we call this, maybe this is the column, and this is the row, right?
Yeah.
Okay. So for column, so I guess we'll for int column. So round. So in C++, this is how we. So 4 round bracket, and then you have to specify your index.
Curly bracket.
Round bracket.
Okay.
So int, actually it should be no bracket around that after the int. And then we have to spell, okay, int column, and when initialize it equals to 0. And then semicolon, and if you recall, this is the I less than, so columns less than 4. And then another semicolon, then columns plus plus. Because we need to show.
Oh, right.
Yeah. So remember, so this is the way you and then end round bracket and then curly. Oh, you only put a semicolon at the end, and then round bracket and then no semicolon at the end. A curly bracket, because now we actually have the loop body.
And right. Yeah. Okay.
And now it's going to make column go from 0 to 4, but now we're on another loop for the rows.
The rows.
So for int
int
rows equals 0. Rows less than 2. Eventually we'll make it 4 with full matrix, and rows plus plus. Okay, hopefully that makes sense.
So now, yeah, that's now it's doing its thing.
Okay.
So it's going to do this 8 times.
Yep. So now we actually have to strobe a pin and read that particular pin, and then set the right one. So so we have to put
digital right.
Digital right.
2.
Okay, and then in this case
it would be column.
Okay, column.
Columns.
Yeah, and because the numbers goes from 0 but starts at a 2, it's columns plus 2. That makes sense.
What?
Okay, well in this case you want to digital right to pin 2 as the output, because that's the first one, and then pin 3 and pin 4. Oh,
right, plus 2?
Plus 2, because if you think a 0 plus 2 becomes a 2.
Right.
And so on. And
then...
Oh, I realized we need to turn them all off first, and then turn one on.
Okay, right. So how do we do that?
Okay, so then we need to another loop here. Okay, so inside that for loop, we need to kind of turn everything off.
Okay, so can we we'll just call dead
for.
Can we have a
for
command
erase.
for erase everything?
Yeah, so we'll call it. Should we make a function, or should we make this inside here? Maybe we should make a function.
I think we should make a function. Just call it nice.
Yeah, to make it easier. So I guess
def turn off.
All off maybe.
What is it, ripple dimming? What is it called?
Maybe output all off, or columns, or all columns off. How about that?
All columns
off.
Off.
Yeah, and you probably want to not make it capital in the beginning, because otherwise it looks like a class. It's lowercase. Yeah. And okay, yeah. In this case, round bracket. Not Python.
Should we all dim?
Or
all dim.
Well, these aren't LEDs.
All outputs dim.
Yeah, but then
outputs off. Let's just say outputs off.
Off for now. Okay. Okay, so then we actually have to set all the pins 2, 3, 4, and 5 off, right?
So yeah.
So then we go maybe for int I equals to 2, I less than 6, I plus plus. And then curly bracket, and we digital right I, comma, off, or 0. Right? How's that look?
Low.
Low. Oh yeah, there we go. Okay, that turns all the outputs off. So now we go into our read keyboard. First we set all the outputs off, then we set the particular output we want. All outputs off. And now we actually set that particular digital right and column. Oh, not I, because around we're in this loop, so it's
columns plus 2.
Plus 2.
High.
So now set that one pin.
Although that'll try and set these guys high too, though, won't it?
No, it doesn't matter, because then we test. Because what happens, it sets one particular column, and then we read if it's actually on or not, if it's in contact.
But right now, isn't it going to go through each column and also each row?
Well, the thing is that let's actually examine what's happened. So, if, for example, let's pretend that this was on. Okay, let's pretend that this was actually D3 that was on, right? This is high.
Should we make a new diagram that's just for 8 buttons? Or can we make fold in half or something?
Let's fold in half, I guess, to avoid confusion.
I don't know if I can fold in half nicely.
Right. Maybe we'll flip it over and just write a new one.
Oh wait, no, I can fold in half nicely. Move it up like that.
Okay, so let's actually discuss what's going to happen. So let's pretend that we set, again, first thing we're going to set all these low. So no voltage on any of these. All these are ground.
Oh wait, crap, I just realized I folded off one of the switches.
Oh, okay.
Can't see the switch. So that's actually where it should fold. Right about there. Fortunately, it's leaving fold marks on our beautiful drawing we made. Oh well. Don't care.
Okay, so let's discuss what's happening. So looking at our code, first it's going to set all these off. So, and again, all these are low.
Yeah.
Right? So now let's pretend that we set this one particular high. Let's say D3, for example. Right? This is high. This is plus 5, ground. As is, what will happen? Well, nothing. Right? Because this input is not reading anything, because nothing's being pressed. So D.
But we don't. That means we don't need to run through those.
No. This is if there's nothing's pressed. But let's pretend we did press it down. Boom. what will happen?
Okay.
Well, that means if this is on, this is pi, and it goes to a connection, then this one turns on. But because we know that we've set this D3 on, and we're reading on a D6, we know that this button must be pressed.
I see.
But if nothing's pressed, we get low.
But we have to read the input there, right?
Yeah.
But aren't we right now setting that to high?
No, we first we have to set high, then we check this one, see if any of these buttons are being pressed in this particular.
Oh, I see.
Yes.
I see. Okay.
And if it is, then we can actually toggle that in our.
So now we're gonna go if.
And then we actually want a for loop.
Oh, right.
Because later on we're gonna have more input. So then for actually no, sorry, we already have it in here because it's. So
yeah.
then,
So
yeah. Okay.
if.
Yeah, so if
Digital read. Digital
read,
and we're reading.
And this is starting at D6, and this is starting at 0, so it's 6 plus.
6 plus.
Rows. End bracket.
Does that make sense?
Yeah. Yeah.
Rows is 0.
Yep.
Or is it 5 plus rows?
Well, no, because
2, 3, 4, 5.
we're looking at our diagram. You see the first. This is our input here.
Oh, right. Yeah,
Yeah,
6
so
plus rows. So
6,
0
yeah.
would be 6.
6, yeah.
So digital read 6 plus rows does equal to high.
And then we actually compute which of these and then actually we set the
So let's just put some
output, yeah.
notes here. So this is
scan through the columns and then read scan the rows. Right? That makes sense.
If digital read equals high,
And therefore, then based on the column and row number, we can actually determine which actually one was set.
give me a second. Let me think
sure.
here for that. So what is this second line doing? If digital read 6 plus rows is equal to high.
Therefore, we know that this particular column and this particular row has been actually pushed down. Else, if you don't read anything, it's not been pushed.
Okay.
Right.
So then now we have to set it high. So we can say
So then we have to use
on our array it would be
yeah. So if we count the number of buttons, actually give these numbering. So let's say that we start from this is button 0, and then button 1, button 2, button 3. This is button 4, button 5, button 6, and finally button 7. So we've labeled this out. So we consecutively name, well, hopefully it's visible on our screen. So this is button 0, 1, 2, 3, 4, 5, 6, 7. So each of these buttons are numbered from this one in this direction. Now we're going to use a certain trick in order to figure out how to sample set a particular button. So let's pretend that we wanted to, this button was being pressed. Okay, this is what one? This is D3 and
D7.
So actually this is the position 1, let's say, and this is on the second row. So this would be, essentially we use, again, this is what's confusion in terms of conventional. This is row 0, 1, 2, 3, column 0, column 1, column 2, column 3. Row 0, row 1. So this is column 1 and row 1 over here. So then we have to set somehow, those two numbers need to convert to 7. This is the calculation we have. So index is going to equal to, well, in this case, it is equal to column plus row times 4. Let's see if you can understand if it makes sense.
Let me think here.
Sure.
Column times row times 4?
Okay, so index, I'll let you type this go. I'd like you to type this go. Index equals to column plus rows times 4. So I realized there should be columns plus rows times 4. Okay, so this actually should generate the correct position of the button index. Let's see if it makes sense. Okay, let's test out. This position is what? This is
0.
0, 0, right? So it'll be 0 columns plus 0 times row. Okay?
0.
0 plus 4 times 0 is 0. Okay, that's
0.
right. Let's do this one here. This is button 1. Okay, so that means this is
1.
column 1 plus 0 times 4. Okay, that's still what?
4.
4. That's 1 now.
1 plus 0.
Because in this case, row is all 0 on this whole thing, right?
Okay.
This is row 0.
Okay, give me a second.
Sure.
So column plus row times 4. So if we're doing this one here, let's say this one here.
Yeah.
This one would be column 2.
Well, column 1. Remember, it's
column
0,
1.
Yeah,
right?
column
1. And row 0.
0.
So that would be 1 plus 0 is 0. Or sorry, 1 plus 0 is 1. 1 times 4 is...
Or 0 times 4.
Or 0, right, is 0 times 4. Okay.
Yeah. So that gives a number of position 1, which is button 1, which makes it.
Okay, so yeah, next one 2.
Let's go to the very end here. So this is what? This is column 3 and row 0. Okay, so we put a 3 for columns, put a 0 for rows. Okay, 3 plus 0 times 4 is 3. Okay, that is button 3.
Okay, that makes sense.
Now let's just go to the next row. Okay, this is row what? 1.
Row 1.
Column 0. Let's just put those numbers in. So column, that's a 0, plus 1 times 4. What number?
4.
4.
Oh, that makes sense. Okay.
All right.
So give me a second. The order of operations. Like I always mess up this.
Yeah.
What's the actual order of operations?
Yeah.
It's
multiplications first and
multiplication first. Then how do you remember all
bedmass?
Bedmass. Okay, yeah.
Brackets. Bedmass. Brackets, exponents, multiplications, division, subtraction, addition, subtraction.
Okay, so now we've got this.
Yeah.
So now we've got our index. So
And
now we have to set the one based off the index.
Yeah.
So it would be
buttons.
So is it up here?
Yeah.
Oh, it's a constant.
Constant. Or actually, we call it shouldn't be a constant because that should just be lowercase because it's actually something that changes. It is a variable, array of variables. Buttons.
So buttons index equal to high.
Yep.
That's it? Or true?
True. I think it's lowercase.
Should we change these to high or low?
Maybe
no, it should be true. It should be true.
Yeah.
I like that.
And there we go. And else, we should do what? That's just outside this. So then else, we need to make it false. Does that make sense? If it's not high, then it should be.
Well, do we do that with the all outputs off?
No, this is actually setting the outputs, but not actually the array. So
okay, so how do we set else?
What? All the same idea. So we recalculate the index. Index equal columns plus rows. Oh, actually, I think we maybe should put that outside this. So
we should.
Yeah, take this
we
index.
Should put that almost at the beginning.
Yeah, put it at the beginning. Because we need to reuse that calculation.
This one here?
Yeah.
Right there?
All right, and then that works. And then, this is not Python. This is...
Oh, right.
Yeah. Switching between languages is tough sometimes. Else.
Yeah, I get confused.
Buttons index equals to false. Okay, hopefully that makes sense. That makes sense to you.
Makes a lot of sense, actually. Give me a second. I have to grab some water.
Okay, so now that we have this now, we actually have a read keyboard function. We also want to actually probably include the serial and write all the keyboards because we want to be able to check what's happening. So we're going to create a new function for ourselves.
Okay.
Yep. So def, I guess, would be right buttons.
Oh, right buttons. What are we doing with that?
We're going to send this to a serial output. Because we want to be able to know whether we're hitting the buttons if it's going to be reading properly.
Okay.
So again, we need
four button in buttons. Right?
Yeah. Oh, actually, no, we can't do this because this is not Python.
Fuck. Yeah, switching between languages is messing my brain.
I think eventually maybe we'll install MicroPython.
That's actually a awesome idea.
Yeah.
Then I wouldn't have to switch between my languages so much.
Okay, so again, round bracket.
Yes,
for round bracket. Int I equals 0, semicolon. I less than 8, semicolon. I plus plus, round bracket, curly bracket, and inside here we're going to serial write. So I believe it was, what was it again? It was serial.print line, I think, right?
Yeah.
Oh, actually, in this case, serial.print bracket, and then we actually want to print the button state, actually, right? So it'll be buttons.
Print.
Yeah, buttons.
Is it a variable?
Yeah, because remember, this holds all our state, right? Buttons, and then there'll be square bracket I, because we want to get that particular button state and write it out.
Like that?
Yeah, like that. And semicolon. And then we want to print maybe a space now, so serial.print, and then space, like that. And so that should be good. And then at the outside of this loop, we want to do a serial.print line, because then we want to have it in a whole separate line. Like that. And we don't need to put anything or a period or something. Or
well, we have to say if it's on or not, right?
Why should you know? There'll be true and false.
Oh, right.
Yeah.
Will it?
Yeah, because
do we need we have spaces in there?
Yeah, because it's going to print Boolean. So when we do the serial.print buttons I, it's going to print a Boolean, which is going to print true and false on the.
Should we try
console. Yeah, but we should also put another print line. Otherwise, everything's going to run together.
Okay, so
after end that for loop, we want to do serial.print line. Because that'll cause it breaking a new line each time. I think that does it, right? So in the loop, what we do is that we have to include serial as well too.
Right.
So we have to go to the top, and before this variable definition, so at the very top we have to include serial, I believe.
Should we look at our other program?
Yeah. Let's go to open recent. Yeah, we have to do that.
But this actually.
Oh no, sorry, it's already built in. Oh yeah, I forgot. Serial's already built in. We don't even need to include it. Yeah, so actually serial's all built. So that should be good now. So we actually have to go into our main loop, read keyboard, and write buttons.
Okay, so we read keywords, write buttons.
And I think also we need to knit the serial, don't we? Let's go back to our code.
Yeah.
We have to set the baud rate, if I recall. So go into our knit function. Yeah, we have to do serial.begin and the baud rate. So that goes into our sep.
Okay, should we start it?
Okay, in the front, did we add in the print buttons? Right button? Okay, yeah. So
let's try it.
Let's try it. Okay, everything's plugged in.
Oh, expected before token.
All right. I see. Okay. Bool button square bracket. Square bracket and square bracket equals to that list. I just So I just remembered how we defined that stuff. Equals, and then I think we put curly brackets inside, if I recall, to initialize. I think in the front of that first false. I think if I recall, this is how we initialize a default array. Let's see if it works. Okay. Oh, def. It is void.
Oops.
Yeah.
Fuck.
We're still in the Python mode, and then a void here as well too.
Oh my god.
And all outputs are void as well too. And anything else? Do we hopefully another void? Oh, we need to. That copy and paste it somewhere. Okay, there it is. That's fine. Let's try it again. All right. All outputs. We've got the round braces. Round brace and round brace. Did we miss anywhere else? Compile. We have to declare a variable in.
Here?
Yeah, at the top level. We don't actually know in there. We actually want inside there. We don't necessarily just have to go inside the read keyboards function at the very top at int index. You have to declare that it's a type. Yep. Let's try that now. So getting through all the syntax errors. Okay, let's see what else is here. Oh yeah, it needs a round bracket side, compile that again. Just getting through all the
I'm doing just Control R.
Done compiling.
Okay, sweet. Let's try it. Upload it.
Yep. Okay, and we open our console now.
I wonder if they can see the serial monitor right now.
Oh, we need to
add that to.
Add it in, yeah.
So we got to go in here and add. We got to reopen that actually. Yep. So serial monitor. And we'll add that too here. Add. Oh, cancel. What would it be?
So it's going to be another window capture. Arduino console. Oh, there it is. I found it.
Perfect.
Okay, so now it looks like we're getting the output up here. Let's actually press a key. See what happens.
Let me make this a little shorter. Like that. That's probably good. There we go. So now we're going to press something here.
Yeah. It is.
It kind of works.
Kind of works.
Oh, it broke. I'm not pressing anymore. It's still getting ones.
Okay. Let me see here. So.
Oh, look! It's taking time because it has to go scan through them.
All right.
In order to know that that button has been pressed yet.
Okay, so it looks like it's not.
Because if I press the first button here. Oh, and it started reading some weird stuff that I didn't press.
Yeah. So it might be loose connections, maybe, or something, or. Yeah. Oh, yeah. Because I noticed that there might be some loose connections, possibly.
Let me just check here. Yeah, there's some loose connections here. Okay, seems to be good now. Press the key here.
Okay,
yeah, reading that one, and then it fluctuates a lot though. Look at that, I'm seeing lots of ones.
Yeah. I'm trying to think what's kind of going on here. I'm trying to think. I think it's because we have to configure the inputs as pull-ups.
Right.
Yeah. Yeah. So input pull-up. Although I realize now it's going to read high all the time, but it might be fine because when we press it should go.
That's weird.
Okay, I'm trying to think here. Oh, okay. I realize we have to reverse it. When we ground it, it's going to register. So we have to flip around that. If this is going to actually set these actually to one ground at a time, otherwise all of them high. Because these are configured all normally as pulled up plus. So the only time we register if a button's been pressed, we need to pull it to ground somehow. So
okay.
Yeah. So we have to reverse
digital write low. This one here, right?
Yeah. And
low?
Then low, and then if we have to read if it's low, then we set it's being true. And the other thing we have to modify is these all outputs off, or all outputs have to be set high.
That's weird.
Yeah. And the fact is because we're using a pull-up over here and not pull down, the fact that we only can register only lows now.
Yeah, that's weird. Yeah. But let's try again.
Let's check the logic. Okay, let's compile. Open our console. Okay, we should let people see the console. There it is again. Let's see if it works. Release.
Oh, it's working perfectly now. Look at that, Alan.
There, we have matrix scanning. The only downside, we can't do two keys simultaneously, so we're going to have to reject multiple keystrokes. But that shouldn't be a limitation, because normally when you're actually streaming, you're not going to do two things at the same time.
You're not going to do that more than that. There's no reason why you would be pressing multiple buttons at a time.
Yeah.
Although, if we want to make, as a future project, like make a MIDI keyboard or something like that, we're going to want to be able to have multiple button presses at once. But right now, we don't need that. So I'm going to call that another successful...
Success number 2 today.
High five. Success number 2. Man, we're on a streak, guys. You know what? If you guys like that, please like and subscribe. And if you guys are watching on YouTube, please comment as to what you guys think we should do next, all right? Because we're on a roll. We're making some good stuff this week. Thank you guys so much for tuning in. And
welcome to the second half of tonight's show, and signing off now.
Yeah. This is the secret half of the stream.
This is the bonus material.
Bonus material. All right, later, everyone.
Good night, everyone.
Bye.
Bye.